Good afternoon, class, and welcome to Food Crops Online Only. I know it's stinging everybody to be stuck at home right now, and it sucks not to be able to get to campus and do our thing out here in the gardens very much. My time here is very, very limited, so I'm just going to do my best to get some video time in and get a little bit of work done while we're at it. Hopefully, this virus thing will blow over. I don't mean to be cavalier about it. I know it's very serious, and I don't think, we're going to have any garden time in here for the rest of the semester. But hopefully, by the time summer rolls around, there will be a chance for people to revisit the garden and maybe get some of your reward for all the work you've done in here. I just wanted to give y'all a little tour of the place and show you some of the work that, it's a good time to be doing right now at the end of March. Let's talk about two of the next big plant families. Probably the two biggest plant families in agriculture, which are the Poaceae, the grass family, and the Fabaceae, the bean and pea family. These are the two biggest families of plants in agriculture. There's two reasons for this. One, they provide the bulk of our calories. Right? I mean, something like 75% of the calories that the human race eats come from grasses, one way or another. Sometimes that's because we're directly eating grain, every time you're eating corn, rice, wheat, oats, rye, or sugarcane, you're eating a grass. And the other reason is that most of what our livestock eats is grass. It's either going to be grain or it's going to be the foliage itself. Then the Fabaceae, the bean family, is going to be important because it also provides a lot of bulk. It obviously provides your peas and beans and soybeans and things like that, so it provides a lot of food we actually eat. It provides an enormous amount of animal fodder as well. But it also has unique soil benefits because Fabaceae are the biggest family of plants. They're not the only ones, but they're the biggest category of plants that do what we call nitrogen fixation. They take nitrogen from the air. The air is something like 80% nitrogen, but it's inorganic nitrogen. It's not usable by plants. They are able to break the double bond in N2 in the air and take those free nitrogen atoms and recombine them into ammonia and then into other things. I forget all the chemistry. Y'all know I'm a bad chemist. But they basically create fertilizer out of air. They don't do it by themselves. They do it by hosting bacteria on their root systems. And we'll talk about that in just a second. So that brings us to our other thing, which is cover crops. Right now we got a few different cover crops in the garden. And most of them are going to be dual purpose grains and covers one way or another. So right by my feet here, I got crimson clover. That's the one that does not provide human food. It does, however, provide bee food, so you might get some of it back in the form of honey. I had one of them starting to flower here. One thing is crimson clover, it's an annual clover, unlike the white clover you're likely to see. It's a good, bee fodder crop. It's a good soil builder. But it's sometimes considered invasive. It's a Eurasian plant. It's a winter annual here. It's from Southern Europe and the Middle East originally, like so many other things. It reseeds like crazy, and sometimes you'll see it included in wildflower mixes for around here. It's not recommended for that anymore because it is not native and it will displace native things like, for example, bluebonnets, which are a native nitrogen-fixing legume. However, for our purposes, we're going to try to not let it go to seed. We're going to turn this under, and then if you look at the T-posts behind me, that's these bad boys. I just pounded these in. We're going to use this for tomatoes, which will benefit from the extra nitrogen. Let's get a look at the nodules that these things are hosting on their roots. So I'm just going to take my shovel and turn over a chunk of this dirt. It's actually starting to dry out enough that we might be able to get we might be able to do some soil work today. And hopefully the plant will cooperate and we'll find some nitrogen fixing nodules on its roots. Wow, nothing. That'll teach me. Sometimes we use what we call an inoculant with legumes. Oh, there's a few little ones, which is just a packet of bacterial culture. It's kind of like buying yeast for your bread, only it's bacteria. It's not a fungus like yeast. There they are. You can see all those little dots on the root system there. Those are and there's a nice worm. That means something's going right in our soil. Those little blobs, when you find those on a legume, they are almost always nitrogen fixing colonies of bacteria that the plant is growing a home for. The plant makes these little nodules on the roots so that it can host those bacteria, which then do the heavy work of the chemical reaction, taking inorganic nitrogen and making organic nitrogen. So the crimson clover here, not only does it add nitrogen in the roots, these dark green leafy tops are full of nitrogen. Remember how, when you eat, crops in the Fabaceae family, so not clover, but beans, soy. If you're a vegetarian, those are your staple proteins because they fix more protein. They're able to make more protein because of that nitrogen fixation than most other plants are. So this is all very nitrogen-rich material that we want to dig back into the soil. Now here, this was kind of accidental. This is wheat. Wheat is, of course, a grass. So here we're in the Poaceae. Wheat does not fix nitrogen. It is, however, going to, because it's not a legume or another nitrogen-fixing plant. A few other plants do it too. The main one that you're likely to encounter around here is Elaeagnus, the shrub that you see over there. That's a nitrogen fixer, but it doesn't nodulate. Isn't that funny? But wheat, as a grass, what it does is, grasses are really good, and this is why they make such a good lawn, is they make a really tough, fibrous root system. Perennial grasses do it even better. That's why prairie soil is so good. Prairie soil is made of thousands of years worth of living and dying, mix of plants, but always including a lot of grasses. Grasses, most of the bulk in a grass, I know this looks like it's got all this wonderful above ground bulk. Most of the bulk is below ground, which means it has wonderful soil properties. As those roots dig deep, they create channels for air and water and for other living things, for bacteria and fungi and small animals. They also then, remember, the roots die. And the roots die anytime anything happens to the top. So say you're, a bison or a cow or sheep. You come along and you bite off half of the top. The plant responds by shedding root mass underground, which means it basically casts off a bunch of its roots to die. The plant does that because it's trying to balance how much roots it's supporting from less food coming in from up top. Well, that may sound rough on the plant, but it is terrific for the microbial community in the soil, which have to do with cycling all nutrients, not just nitrogen. So when you don't have to cover crop with a grass and clover together, but when you do, you get the benefits of both. You get the bulk fibrous root mass, you get tons of leafy top material from both species, and you get the nitrogen fixation from the legume. We've got another example of it over here. I'm just going to step on my field a little. This is a mixture of winter wheat. When we say winter wheat, by the way, it just refers to when it does most of its growing. Around here we grow winter wheat. Winter wheat grows all the way up north, at least as far as my neck of the woods in Wisconsin. You plant it the same way you plant garlic. You plant it in fall, typically October, November, and you let it grow over the winter when you get this luxuriant, beautiful growth. In Wisconsin, you don't get this. You get some green and then it just stops and hides out under the snow. And then it grows gangbusters the next spring. So here we've got this mixed with winter peas. Now these are a cultivar of regular old, garden peas, the same kind that you get pea pods or the peas in your fried rice from. These, however, we grow mostly as a cover crop. They grow tons of leafy top